Mrs. Culver from SeaTac, and we have...
It's Bianchi from Thorogood.
Yep, and we are the dynamic duo of Oysters, and we are here going to show you how we're going to collect data from our oyster babies. We are here at the Virginia Aquarium. This is Owls Creek, and we love being partners with Virginia Aquarium because we are right next door at SeaTac and right down the road just a little bit from Thorogood. So here we are. Miss Bianchi has been working out to get this float, which is floating in Owls Creek, out of the water for us to look at our babies.
And this is exposed because it's low tide. So usually it'll just be floating and you'd only see the white PVC pipe. But right now, since it's extremely low tide, as you can see, everything's exposed over here, then that means our oysters were exposed, making it a little more difficult, but that's okay.
And the last time that we saw our oysters was back in, I think it was October.
Yes, October, and they've definitely grown because they are very heavy.
So we're going to see what difference we've had since October.
Well, and I had a feeling they would be bigger since they, we have not had any snow or ice, so it has not been very cold, and cold weather makes them go dormant and they slow down, but we have not had that. So I was hoping that they were pretty big.
So we're going to check to see different elements and how they interact with each other. So we're looking at temperature, water, and our baby oysters.
Yes. And so this net is what they stay in while they grow. And once they reach a certain size, we'll trade it out, which feels like soon we're going to need to do that. Probably the next time.
Different size nets.
Yep.
I'm going to bring this over to the dock. And we have zip ties to keep it closed.
Yep. So the reason we have different size nets is because they'll need space to grow, but they also still need water to flow through them. Since they are what we call intertidal organisms, meaning they can be out of the water, but only for a limited amount of time. And then otherwise they need to be in salt water.
So we're going to cut off the zip ties. It's like opening a Christmas present because we don't know what exactly we're going to see yet.
You can feel them, they're heavy.
So it's really exciting.
Then we make sure we pick up all these zip ties so they don't go back in the water.
Because we know anything that goes here can go all the way to the ocean.
Right.
Okay. And just want to point out that this is Owls Creek, which is our school, SeaTac, that's our watershed. And your watershed at Thorogood is?
Thorogood.
It's Lynn Haven.
Lynn Haven.
Yeah.
Well, and the water back in Thorogood. Oh, yucky. Okay. Wow.
Oh, they're so much bigger. Oh, I forgot to bring the big ones.
So they started as these really, really, really tiny ones, basically the size of your pinky nail. And now we have some that look almost 60 millimeters. So
yeah. So we're going to collect the data because we're going to see how much they've grown.
And we are in charge of tracking the growth.
Because eventually, by the end of the year, we are going to take the oysters and transplant them to make an oyster reef.
In a sanctuary where they cannot be harmed. All right, so I'm going to start with these.
And I'm actually going to take a hand lens.
I think these are some of our biggest ones. So far, no predators. Not seeing any crabs. I'm really not seeing any open ones either. So if those of you that remember, open means dead. So far, no dead ones.
But it's the different sizes. But these are probably some of our bigger ones that we've done.
Definitely. And Miss Culver, do you remember why some of them start to become connected like this? Do you remember why that happens? Because I think that's a very important piece. So when we put these back in the water, the reason they say throw your oyster shells back in, even if you've eaten them, which it is okay to eat them when they're grown, but we say throw the shells back in because they start to colonize together. And that's why you see an oyster bed is they start to stick together. So eventually all of these would end up stuck together, and that's how they would live. And that's how they stay safe.
So this is positive that they're stuck together.
Yep, they have grown together. Alrighty, so let's measure some of these guys. I don't know. I think our smallest is probably that one in this bunch. That's usually what they look like when we put them in the water.
This one's really big.
Maybe even smaller. Yeah, that one's really long. So is this one. You can see the difference there in those two.
Yeah.
So this image is a range of where they will get to, at least in the 6 months that we have them. So they will continue to grow, but this is about what we should see by the time we're done with them. So if I take this one and I'm working on measuring in millimeters, it's kind of hard to see with it being clear. And I put this at the very end. I guess I would have to start, oh, I'm going backwards. Put the hinge at the end. Let's see, probably, what do you think, like there?
Yep, 2.
Yeah. So it would be pretty much 20 millimeters. So that's probably one of our largest.
Let's do this little tiny one.
The tiny one?
With the hinge there, you said?
Yep, the hinge at the end. That put us really at about a half. So, 1/2 inch. And we can count them. 1, 2, 3, 4, 5, 6, 7, 8. Well, a little more. 8 millimeters.
So looking at the comparison of the two. And they're all together, so that's just so interesting how different ones grow. And we've talked about the temperature affecting them. So we want to take a sample to collect our data, is that correct?
Yes, and so what we'll do is we're going to take a handful. We're going to do about 50 of them, and we're going to write them down. And you can use any ruler, either in centimeters or millimeters. So this is the one that was attached on the measuring sheet. And so we could see that this one was a little over 4 centimeters. And this we really would count that only at about 1 centimeter at this time. So we're going to take our random sample. And like I was saying, we have not had any snow or ice at this point, which is partly why they've grown so well. So let's see, those were...
And we want to put the date, right?
Yep, we're going to put the date.
And let's put the time just to be accurate.
What is our time?
Our time is 2:36.
Okay, and we should probably look up our water temperature at some point. I don't have the...
Do we know our water temperature? No. Okay.
Google can tell us.
Yes. We'll look that up in a minute.
So.
All right. So do you want to do you want me to do that and you give your data?
Sure.
Okay. Or do you want to just do mine and then yours?
If you just want to do that and say it to me, I'll write them down.
Okay.
Then we can see what our biggest ones are.
All right. 4.5 centimeters. Are we looking at the biggest ones?
No, it's a range because
Okay.
they want, we need to have the average, so
Okay.
the little guys count too.
Okay. All little ones count. 3 centimeters.
And then especially if any of them are open, as that would be a death, but we would still throw it back.
3 centimeters. 4 centimeters.
So far, lots of 3s and 4s.
Yeah. 3.5 centimeters or 3.5.
Yeah. The fraction and the decimal.
Yeah. Woo, 5 centimeters.
Ooh, that's a big one.
Yeah.
So the sea temperature is 46 degrees.
46 degrees. All right, so the water
Well,
is
thank
46
you, Rachel.
degrees, which is
At least it's
Fahrenheit.
right there out in the ocean, right?
Yeah, which is actually not far off from what our air temperature has been, so they're pretty close.
Where do you see that, Rachel?
Like the wetsuit guy.
Yeah.
All right, the last one was 5 centimeters.
Got it? We'll just do 20.
Okay, no problem. 2 centimeters. 3.5 centimeters or 3.5.
Okay.
2.5 centimeters or 2.5. 4 centimeters. 4.5 centimeters.
This is pretty big because some years in June I'm just now hitting 4 centimeters.
Exactly.
So they've really done well this year.
COVID year.
Yeah.
Go figure.
One really good growth during COVID.
3.5 centimeters.
Right. That's number 14. So.
Okay. So the year for the oysters is 2020, 2021. 3 centimeters. 4 centimeters.
What also is really interesting, I did not see any bloodworms, crabs, any predators.
I
going
know.
on.
We always have those.
No.
The children love seeing those, actually. 3.5 or 3.5 centimeters. What number are we on for our data collection?
We have 3 more.
3 more. Some of them are wide, but not long.
Yes.
2.5 centimeters.
And that edge is very, very sharp, so you have to be very careful.
Yes, we usually have our gloves, but we've done this a while. So this is our, what, 4th year?
Yeah. Well, my, 9th year.
Yes. 2 centimeters.
Oh, that's a little guy.
Just a little one. 3 centimeters.
All right, that was it.
Okay.
All right.
So we did a collection, a sampling. We did not measure all of ours, but we're going to take the average of our data. So that's why math and collecting data, being accurate, is very important. Can you walk them through the process of what you're doing to figure that out?
Yes, I was about to say, I wonder if they remember how we get the average. So in order to get the average, we're going to have to add them all together. So this is going to take me a minute to plug them all in. And then I have to divide by my total amount. And that will give us our average. I wonder if they could guess what the average might be.
So thinking about all the numbers that you heard me say, we talked about a lot of halves and wholes. What do you think the average of the